are a team from American University of Beirut, and Ghali was a graduate student, and I'm an assistant professor at AUB. And then we have our third author, co-author Samir Mdanat from Ghafari Associates. So today we're going to talk about the last parent system and the need for new metrics. So this is the outline. So we're going to start with the introduction, and Ghali will show us the metrics that already are in the literature, and then I'm going to come back and talk about the proposed new metrics, and then we can end up with the conclusion. So we all know about the last parent system, how it shifts the planning and production planning from being push, where everything happens according to preset schedule, to pull, where we are actually taking into account the status of the system and the need for tasks downstream. We also know about the collaborative planning process and pull planning and all of those things, and how also we shift the control from being reactive to proactive, especially in terms of removing constraints ahead, look at planning, weekly work planning, all of that. And this has resulted, when applied correctly, in improving the planning reliability and reducing workflow variability, and these are the goals of the last parent system. However, as Drucker said, if you can't measure it, you can't manage it, and if you can't manage it, you can't improve it. So hence, the need for proper metrics to measure and improve our production plan. And this is where this actually the motivation for this work. Many researchers have actually come up with many metrics to help with this process, and Ghali will take us through this journey until we get to the new proposed metric.
Hello. So now we're going to review the most common metrics found in the literature review. First, Dr. Grant Ballard suggested the most three common metrics: percent plan complete, tasks made ready, and tasks anticipated. As we all know, PPC is the most commonly known metric. It's the number of activities executed over the number of activities that were placed on the weekly work plan. The metric is a post-production measure, and currently the common understanding is a high PPC is automatically means a successful implementation of the last parent system. Tasks made ready and tasks anticipated were proposed to align the long-term with the short-term planning. As we can see, task method is the amount of activities executed from the activities that were made ready at the last stage. Task anticipated is activities based on the work plan that were anticipated 2 weeks before. Also, Shita and Abdel Hamid start to compare the process improvements compared to labor utilization factors versus improvement based on PPC. They define labor utilization factor as effective work plus 1/4 essential contributor work over effective plus essential contributor plus not useful. And this was as productive and not productive time. They reached a conclusion that we should work on process improvement based on PPC, as LUF is only a measure of local production activation. Dr. Monteporos tried also to align work to align the long-term and short-term, and he proposed 3 data and planned work ready. The three data were put to indicate the amount of constraints by constraint analysis. Data 1, data 2, data 3 shows the number of constraint promised to be removed over constraints identified, compared with the actual move over constraints promised to be removed, respectively. Constraint analysis can be useful, however, it may be a bit problematic as constraints cannot be counted and measured properly, and they differ from project to project. Finally, planned work ready measures work expected to be performed versus work that should be performed. John and Kim also proposed some make-ready metrics. As we can see, the proposed percent constraint removal, which is the amount of activities that were ready over the number of activities that were seen in the work-ahead plan. And interesting, they found a correlation between PCR and PPC as strong one, around 0.875 correlation coefficient. Dr. Gonzalez and his colleagues also tried to reformulate the matrix on the activity level matrix instead of project level matrix. The two metrics they found were project productivity index and process reliability index, and both were correlated with PPC. One measured the actual productivity on site compared to the maximum labor productivity, and the other the actual progress compared to the project progress. Okay, so Piven et al. And Dr. Faraz Sachs also tried to measure workflow. They proposed the lean workflow index. As you can see, the weight of each parameter, A, C, D, E, F, which are the product of the root mean square of the flow line, the percentage of time with no breaks, the percentage of time close working parts work out of sequence, were calibrated in an equation based on location-based cadence flow lines. The higher the number, the more continuity in the flow lines. Last year, Dr. Grant found the need to better align long-term and short-term, so it proposed three new metrics, C, RP, RCO, and MV, which are commitment level, percent required and ongoing, and milestone variance. Commitment level is the number of required activities on where compared to the required as critical activities on the look ahead. PRCO is a required complete plus going on track of the required work. We found that teams that replan to maintain these metrics had a lower milestone variance, standard deviation between the dates, date promised versus the actual date of the project. Finally, my colleague Risk et al. Found the need to match load to capacity. And thus she proposed a couple of new metrics. As you can see, her metrics differentiate between weekly work plan, new activities, and backlog activities. She proposed the capacity to load ratio total executed over the weekly work plan, the weekly deviation between the activities, total executed minus the ones that were placed on the weekly work plan, required capacity ratio, the number of required activities that were executed from the ones that were placed, required as critical, required percent complete, the ones required from the total, the ones that were critical activities that were executed over the total required activities. And now Dr. Farouk will continue with describing the problem and proposing new methods.
All right, so a lot of metrics are already there, and maybe I don't know how much we're using them, but also we found out that many of the metrics are also linked to PPC, and we all see that actually a good implementation of LPS is directly related to PPC, which is the industry standard. But also there are certain things to be complemented there. PPC naturally assumes that all tasks are equal. And if you see the pipeline diagram there, not all pipes are the same. Not all tasks have the same size or the same criticality or the same, or how much they open tasks downstream. Not all of them are equal. Not all tasks are equal. However, when we count PPC, all tasks are equal, independent of whether they're critical or not. If we look also in terms of industry, many of these metrics are inconsistently used. We don't know who's using those metrics. We don't have a standard way of applying those, and there is no clear correlation between metrics and performance. Okay, if I have a higher metric X, what does that mean in terms of overall project performance? Am I better on time, better on cost, better on quality, better on what value? So it's not very clear the correlation between all of those metrics. So that's where we found actually some of the needs. We don't know when you have a PPC of 80%, so this means 20% of the tasks are not done. What if those 20% are critical tasks that will delay your project, versus another 80% where the 20% that are not done are not critical. So those two have the same 80% PPC but different status. So that's why we wanted to create some other metrics to show this difference. And also we found out from actual data on construction projects with the help of Raffaele Institute that actually there's a high number of tasks that are uncommitted but are done, executed from uncommitted, which is a huge variability. Remember that what we're trying to do in the last current system is to reduce that variability, but we find out there's a lot of variability. How can we measure that? So that's why we have this question. Uncommitted tasks, how can we measure those? The executed from uncommitted. And then last, we want to know, if you execute a task that has 100 man-hours versus a task that is 1,000 man-hours, are they the same? Those are not the same. What if the task that opens only one task downstream versus the task that opens 100 tasks downstream? Are they the same? On PPC, yes, they are. It was done, executed, one over, they're the same. So this is where we wanted to create some new metrics. Hence, the proposed new metrics. So these are the new metrics that we are proposing. Required level, completed from uncommitted, LHRI, which is the related to labor hours, and then progress priority. I'm going to explain one by one and show how they work. So we start with the first one, completed uncommitted. So these are tasks that we are completing on a weekly work plan, but we have not committed to those at the beginning of the week. So they are completed from two batches, either from those tasks that we call new, and we have published some papers that what does new mean? New means that those tasks have not been broken down from the look-ahead plan. I'm going to execute a task that I put on my weekly work plan. I found out, oh my God, I need to do this before that, but I haven't put it on my weekly work plan. Now I have to do it. So that means that I have to now allocate some capacity to those tasks. Capacity that I have not thought before that I need. Now I need them before I do the tasks that I need. So this is one. Next is the executed from the backlog. Remember, the backlog is my plan B. It is great if I execute those tasks when I'm done with my task. If I'm done with my task and I execute from my backlog, this is great. But if I am executing tasks from my backlog and I'm leaving some tasks on my weekly work plan not done, then this is alarming. This is where we want to study. So this is what this metric actually does. It measures those that are completed from the backlog over all executed from the backlog and from the new. It's a factor. And the higher that factor, this means the more that I'm executing tasks from the uncommitted batch. So it's telling me there's some variability. So this is the first factor. So the best way is to show how does it work. So let me see. Okay. So how does it work? So this is, I'm showing a weekly work plan here. So if you look at the first row, it says the planned and executed. So I have 8 planned that are critical. Critical, this means that they're delayed the project. 7 are non-critical, but both are on the weekly work plan. So my weekly work plan has 15 activities, 15 tasks. Out of those, I'm executed 6 which are critical, 4 that are non-critical. So if I measure my PPC, it is 10 over 15, which is 67%. Okay, that's good. Now I know that my PPC is 67%, but let me see what about the others. So if I check my committed, completed, uncommitted, I see that from the new, there are 2 tasks that are new, 1 is complete. Backlog, I have 9, and 2 from the backlog that I have completed. Let me see, does this work? Okay, so 2 from the backlog that are completed. So this means my completed and committed is 3 out of those 2, all of those. So 23% of my committed tasks, of my completed tasks, are uncommitted. The higher this number, the more I have variability. So I think this is to tell us something. So this is the first metric. Now the second one, okay, let me go back. Sorry, I missed the. Okay, so the second one is required level. Required means critical. So this is another name that actually Samir came up with this. So I didn't want to change it because he used it in Iglc in Boston. So we continue with that. So required means critical task. So this is the ratio of tasks that I'm putting on the weekly work plan. How many of those are critical? If I have 15 tasks on my weekly work plan, how many of those are actually that critical and how many are not? And this number actually tells me something. The higher it is, this means the more my back is against the wall. If my RL is 90%, this means 90% of my tasks on my weekly work plan are critical. This means my back is to the wall. So this is why we are also measuring those. So if I take a measure here, so if you see, to measure the RL, my critical tasks are 8 from 15. So for this week, 53% of my tasks are critical. Okay, next we move to reliability, to actually workflow metrics. So here what we measured is the percent of work completed. How much is the man hours? We're talking about expected, not actual. Okay, compared to total labor hours. And here we're assuming that not all tasks are equal. So you see there are pipelines, there are some big ones and small ones. Big ones means more labor hours, smaller ones, smaller man hours. I'll give you an example. So look at this project, this weekly work plan. We have task A to J, and each one I put the labor hours. These are the plan. I'm not talking about action. I'm not measuring productivity. I'm not just measuring how much work we're opening. I'm measuring the pipe. So if you look here, 3 out of 10 are complete, 100%. My PPC is 30%. But if I measure my labor hours reliability index, so how much labor hours I have finished this week compared to plan, I would add the percentages. I multiply them by the hours, labor hours. I find out 2470 over 2900, so 85% labor man hours reliability index. So I have finished 85%. Now compare this to another case where actually I finished 90% of my tasks. So my PPC is 90%. So great, lovely. Compared to the other schedule, which is 30%, is much better, right? Now let's look at the labor hours reliability index. If I multiply those, it's lower. Check activity F. Activity F has 609 hours. It's a huge activity. I haven't done it. In PPC, it counts as 1. Here, it counts more. Why? Because it's a bigger task. It has more labor hours. It opens up work. Maybe it is a huge area. So that's why this is that. Okay, so then we have the last one, which is progress priority. Progress priority tells me how much work I open downstream. So this is using something called time plus sum of sums. Sorry, using the word sums. Let's use sibling. So all the tasks that come afterwards. So I add the time of the task plus the task that come afterwards. So the higher the number, this means that you open more work downstream. Okay, so just check these two scenarios. In scenario 1, I have B and C. You see, they are in parallel. But B has a number of tasks downstream more than C. So if you check there, if I execute one of them, PPC is 50%, but my progress priority for the first scenario is 57%, because when I finish B, it opens more work downstream. With the other one, also my PPC is 50%, but because C has less number of tasks and lower duration downstream, my PP, which is progress priority, is less. So this is where we're showing this difference. So I'm almost done. One moment, I'm almost done. So this is the map of all the metrics, and you see our metrics, they follow in workflow, reliability, critical tasks, and weekly work plan. All of those, this is where they follow. So in summary, in conclusion, let's see if this will move. Will it move, the conclusion? No? Okay, sorry. So, current situation, there's the need for metrics to complement PPC, not enough research on actual projects that show the predictive power of metrics in isolation or in combination. That's why in this we're contributing to these metrics. First, required level takes into account critical tasks, committed, finished on uncommitted activities takes into account the uncommitted ones, which is CU. Then LHRI and PP take into account labor man hours and successor activities. So recommendation, we recommend that people, when they incorporate those into their lifespan system, they will become more aware of those variabilities. Then, hopefully, we'll have a standardized way of applying the lifespan system. And currently, we're applying those metrics on 2 projects from the US with the help of the Paris Institute, and we have some initial results. Hopefully, we'll report in the next IGS. Thank you very much.